we get right into this because we're going to now look at ellipses that have center at HK. Not just going to narrow it down to look at only ones that have a center at 0, 0. Now H could be 0 and K could be 0 and all this still will apply. But this will allow us to have more general forms so that we can graph all sorts of types of ellipses that have horizontal and vertical major and minor axes. So I've got a couple of sketches made out here. I put HK here in quadrant 2. Over here I put HK in quadrant 1. That's just arbitrary. But you can see that the distances are still going to be the same. From the center to the vertexes A, from the center to the co-vertexes B. From the center to the vertexes A, from the center to the co-vertexes B. So you're going to just be adding to the X or to the Y values of the center to find these key points, especially when we're doing some sketching. Now, when we write our equations like this, and I got a little check mark next to each one, I'm not sure why, but when I write the equations in this form, I'm looking at what we call standard form here. The standard form for these equations are in the form x minus h quantity squared all over a squared plus y minus k quantity squared all over b squared equals 1. Notice the h and the k there, that's your center. That's your center up here. Same thing over here, except that the b squared is underneath the x variable because this one's elongated over the left horizontally, this one's elongated vertically. Our center is still HK as I mentioned above, but look and see how the vertices have changed a little bit because you're not going from 0, 0. You're going above, to the right and to the left from HK, so it's going to affect adding A units to the H, subtracting A units to the H, and for the minor axis, adding subtracting B units from the K. The other way around over here, for the vertices, it's above and below, so we'll be adding A units and subtracting A units from the K. And to get the co-vertices right and left, we're going to be adding and subtracting B units from H. The foci, of course, are on the major axis, so we're adding C units or subtracting C units from the H on the horizontal and on the vertical from the K. That's a lot to keep track of. You'll get used to it as you practice the problems, including which we have some practice problems right here, although it looks like I forgot it. There we go. All right, now, when you're graphing these are a little bit tough to graph to begin with, and if you just graph something down like that for your axes, it's not going to look even close. And some of you keeps doing stuff like this, where you're just freehanding the points instead of using graph paper or at least using a straight edge to measure them off so that they're equal spaced out. I would suggest that you get some graph paper, and if you don't have any graph paper, you can print the graph paper that I have on my site, or you can just, find it by doing a search. So now I'm going to graph these, this ellipse here, which is in standard form. It looks a lot like this guy because the bigger number is underneath the X. So this is going to be elongated horizontally. And then I'm going to identify the center, the vertices, the minor axis endpoints, or the co-vertices, and the foci. Well, the center I need right away, so I can't mess around with that. The center is HK. Now notice it has to be in the form x minus h. This is not x minus, this is x plus 1, but we can think of that as x minus a negative 1. Kind of the opposite of what it looks like. So my center is negative 1, positive 2. Negative 1, positive 2. Now that's not part of my graph, but I'm going to use that to find my vertices, the points for my vertices and for my co-vertices so that I can make a reasonable sketch. If I can get those 4 points, I can come up with a halfway decent sketch, although, as you guys are aware of, my sketches are, well, they're not so great. We'll do the best we can here with this next one though. And since A here, this is A squared, so A is 5, and B is 3. I'm going to go 5 units to the right. So that's 1, 2, 3, 4, 5. I'm over here at 4, 2. I'm going to go 5 units to the left. I'm over here at negative 6, 2. Those are my vertices. My co-vertices are going to be 3 units above, because B is 3. 3 units above the center, 3 units below. 1, 2, 3. This is negative 1, 5, and this is negative 1, negative 1. And now I'm going to try, anyway, to come up with a reasonable sketch. Doesn't have to be perfect. Just do the best you can. That could be better. And so my center, here, I'll put it down here. My center is HK, which is negative 1, positive 2. My vertices are A units to the right, A units to the left. So from this point, 5 units to the right, that puts me at 4, 2. And it also puts me 5 units to the left, that would be negative 6, 2. My co-vertices, or my minor axis endpoints, are going to be B units, which are 3 units above and below. So 3 units above would put me at negative 1, 5. 3 units below would put me at negative 1, negative 1. Now my foci in this case, I have to figure out what C is. Now I have the same relationship here, whether your center is 0, 0, or HK. So that tells me that 5 squared is equal to 3 squared plus C squared. C squared is equal to, this is 25, and 9, 16, C is 4. So I'm going 4 units to the right, 4 units to the left from that center. So 4 units to the right at 4 would give me 3, 2. 4 units to the left, subtract 4, would give me negative 5, 2. I think I said add 4. I think I said add 3. And there are all my key values right there, and there's my graph. Again, and on these graphs, use some graph paper and take your time. Don't just look at some image of it that you found online or in a textbook and you just try to kind of copy it from there, put the tracing paper right over it. But make sure that I can see that you not only have the center, but that you have these 4 key points, the vertices and the co-vertices, when you do the graphs. All right, the next example doesn't actually ask for us to do any graphing, but as you can see, the equation doesn't look anything like standard form. We have 2x squared plus 11y squared minus 12x plus 44y plus 40 equals 0. That doesn't look anything like we're used to seeing. Let me write her down again. This is for part A here. We're going to write this equation in standard form, so it's going to look like one of these two guys here. Let's see, minus, make sure I write it down right, plus 44y plus 40 equals 0. Now what would make this look like this? Well, you can see you've got the variables, the x and the y. You've got binomial squared. You are going to have to complete the square for the x's. You're going to have to complete the square for the y's. So that's my first step, which means this guy, I'm going to take him to the other side. I'm going to write this guy next to this guy, so I have 2x squared minus 12x. I'm going to write this guy next to this guy, plus 11y. Wow, I keep getting phone calls from senators and presidents and all sorts of stuff here. Rock stars, baseball players, plus 11y squared plus 44y equals negative 40. All right, I don't know how they keep getting my number. So now I'm going to complete the square for the x's and for the y's. Here I'm going to factor out, because I need a lead coefficient of x squared. Remember to complete the square here? To complete the square here, I'm going to factor out the 2. That's going to leave x squared minus 6x. Now I'm going to leave a little space there so I can complete the square. Here I'm going to have to factor out the 11. That's going to give me y squared plus 4y. I'll leave a little space there, and then equals negative 40. Well, to complete the square, I would need to take half of negative 6 and square it. That would be plus 9. But I didn't really just add 9 because the 2 is in front of the parentheses. By putting the plus 9 there, it's going to be multiplied by 2. I've added 18. So I will add 18 to the other side. Here I'm going to take half of this, which is 2, and square it. That's 4. So it looks like I added 4, but I actually added 44. So I'm going to add 44 to the other side to keep everything nice, neat, and balanced. So this is 2 times the quantity, x minus 3 quantity squared, plus 11 times the quantity, looks like y plus 2 quantity squared, and that equals 22. Well, this at least has the parentheses, and at least it has the x minus h and y minus k that I want, quantity squareds, but it still doesn't look like that because I don't have it set equal to 1. So now let's divide by 22 to make this 22 over here and make that equal to 1. So I can simplify a little bit, and I have x minus 3 quantity squared all over 11 plus y plus 2 quantity squared all over 2. Make sure that's a plus sign, equals 1. Whew, that took a while, but there I am. So now what I need to do is I need to turn on the TV to make sure that you guys are getting a a reasonable picture of the screen here. It's hard to tell on the camera. Let's see, do we have everything? We have everything shown. Although it looks like the 44 got cut off just a little bit. That's a plus 44 there. So now my center is HK. H, this is x minus h, so this is 3. This would be like y minus a negative 2, so negative 2, HK. It is elongated horizontally because this number underneath the x is bigger than this number underneath the y. So it's fitting this form here, which means a, by the way here, a squared is equal to 11, so a is equal to the square root of 11. B squared is equal to 2, so b is equal to the square root of 2. So to find the vertices, I'm going to go a units to the right and a units to the left, but it's not a nice integer. It's the square root of 11, so watch how I write this out. I'm going to write this as 3 plus or minus the square root of 11, negative 2. All right, now I could write it as two ordered pairs, 3 plus the square root of 11, comma, negative 2, 3 minus the square root of 11, comma, negative 2. But this is fine. I didn't do that back here because I got integers and I didn't want to write, you know, negative 1 plus or minus 3 or something like that, or plus or minus 5. So I'm going to go ahead and leave it in this form. My covertices, or minor axis endpoints, would be the square root of 2 units above and below. So that's going to be 3, negative 2 plus or minus the square root of 2 for that. And then I'm going to get, I need the foci. And the foci are going to come from finding c, which I don't have. But again, a squared is equal to b squared plus c squared. So that's 11 equals 2 plus c squared. C squared equals 9. C is equal to 3. So it's going to be 3 units to the right and 3 units to the left of the center here. So this time I'm not going to use the plus or minus. I'm going to write the foci would be 3 plus 3, or 6, negative 2. 3 minus 3, or 0, negative 2 for my foci. So it just takes a little practice and a lot of algebra there to be able to come up with all the information that they asked for. And I think I did. So just remember to practice, practice, practice.